requirement engineering refers to the process of defining, documenting, maintaining requirements for engineering design process, creating the reasons for developing software acceptable to the user. What is technical feasibility? That evaluates current technologies which are needed for the customer requirements within the time and budget. Good morning and welcome to the second session in 5th semester Unit 2 Software Engineering B.Ca, where we're going to talk about requirement engineering. Now, what is this word requirement engineering all about? Though it might sound quite technical when I'm going to use those big words, but nevertheless, requirement engineering refers to the process of defining, documenting, maintaining requirements for engineering design process, which means to say that this is basically a collection of all the factors that are needed to complete the project on time. So when I talk about the requirement process, it starts with defining the items, documenting it, and then start maintaining that requirements as per the project requirement, as per the project need. Now, this also provides an appropriate mechanism to understand what the customer desires, analyzing the need and assessing the feasibility. Every project must be created and completed with the requirements of customer in mind. So whenever we are doing the project, you have to think from the customer standpoint rather than your technical expertise. So this requirement engineering would provide us the factors of how to analyze it, where we need to fit in the data, how do we need to assess the feasibility according to the customer. We can also get on to negotiating a feasible or a reasonable solution, specifying the solution clearly, validating the specification and managing the requirements so that they can be transformed into working system. Now, the second part of the project is that though the customer wants something unique, special, but again, it comes back to the point whether we will be able to do exactly what the customer is asking for. Sometimes it becomes very, very important to understand this factor that everything is not feasible according to the customer. Now, so we have to bring in certain feasible solutions. We have to bring in a negotiation factor through which we arrive at a conclusion so that we are able to address the needs of the customer, and at the same time we are able to bridge the gap in terms of the customer and client and build a working system that is feasible and that can be taken forward in terms of the business development. So the requirement engineering has got many phases which goes in depth for us to understand and make the project successful. Followed by which we are going to understand the step-by-step process, which includes feasibility, requirement, software requirement specification as we are speaking about, and validation factor, and then the requirement management itself. So when you look into the steps, the first one is feasibility, the second one is the analysis part, specification, validation, and the management. So the step is very, very simple. So let me just put it here. We'll start with the feasibility study. We will go into the analysis. Then we go into the specification. Then we go into validation. And then we go into management. So you can remember these keywords SASVM, which means to say that we are starting with the study, analysis, specification, validation, and management so that you would be able to write well in the exams. Followed by which, let's start with the feasibility study. What is a feasibility study? Which means to create the reasons for developing the software that is acceptable to the user, flexible to change, and conformable to the established standards. Now, we have three phases that we have to understand in the feasibility study. Let us start going one by one here. The first one is that creating the reasons for developing software acceptable to the user. Who is the person who's going to use the software? There is an end user. So according to the end user, the software needs to work. It cannot be functioning as per the company. It has to function according to the convenience of the user. So that's very important. Is it flexible enough for change? Why do we talk about flexibility here? Because in case if there are some changes that needs to be added, something that needs to be appended, something that needs to be added up for the future versions to come, it should be flexible enough. It should have that capacity to accommodate change at any given point of time. So flexibility is a very, very important concept that we are talking here. Followed by which we are talking about established standards. Now we are coming to standards, we are coming to the norms of how the project needs to be there. It needs to stick to the norms and standards of the project. It is not something we can just develop and leave it in the air. So it has to follow all the rules and regulations that has been laid down, and then the entire feasibility study is completed. Now, moving on to the feasibility study, we have the types of feasibility, starting with technical feasibility, operational feasibility, and economic feasibility. Now, this is quite easy for you to understand because the words itself are self-explanatory. Let's start with technical feasibility. What is technical feasibility? That evaluates current technologies which are needed for the customer requirements within the time and budget. So whenever I use that word technical, that means to say that we are talking about technology. The current technology that can be used for making the customer easier to use the app and build it accordingly. Followed by operational feasibility. What's an operational feasibility? Now I'm talking about required software that is used to assess and perform a series of level and solve the business problem and customer requirements. Operational, that means the day-to-day working of that software, that is very much needed. Economic feasibility, where I'm talking about the budget, cost and time factor so that it is coming within that given time frame. Followed by the second part, which we're going to talk about, requirement elicitation and the analysis part. Now, this is also known as gathering of requirements. Now, this is very, very interesting. Why? Because I'm using this word gathering, which means to say that it's a collection of data and we're going to identify with the help of customer the existing process if available. Now, the most interesting part, coming back to this entire software project management or the engineering part, is that we intend to do repeatedly the same thing in terms of project management. So sometimes it's always advisable, it is smart enough that we go back, inquire with our customers, find out is it the same thing that they are looking for. Because you might have done the model some years back, you might have done the same kind of project couple of months back, couple of years back. So you can replicate the process, save time, save money for the customer and give him the best possible solution. But sometimes what happens is that the customer might not be happy. He definitely wants a unique solution for himself. So that's where analysis of requirements starts with the elicitation, where we start identifying what are the inconsistencies, the defects, the omissions, etc. So we go back, we find out where are the gaps in the project. Once we have identified the gaps, we can resolve the conflicts and then we can take it forward. The next one, requirement elicitation analysis, also gets into getting all and only the right people involved. That's very, very important. Why? Because we are not going to include each and everybody, but we are going to look into people who are the right stakeholders for this project. So once we have brought the right people into the project, we know that this project can be taken forward. Stakeholders often don't know what they want. This is very, very important and interesting. As a customer, I just want a software application, but I exactly do not know what I am looking for. So it is the job of the company, it's the priority of the company to identify exactly what the customer wants. So a bit of consulting is needed here to understand what exactly is required from the stakeholder standpoint so that we can get the exact software, we can get the exact thing, and the working would also be more efficient. Followed by the requirements in their terms, and we need to understand that we resolve all the conflicts at the initial level. We should not get carried away. We should not underestimate or overestimate the customer requirements. Try to match what exactly the customer wants, so that at the end of the day, we first resolve our conflicts. We don't take it to a stage where the entire project breaks down. Instead, we can understand what are all the requirements and the changes are needed during the analysis phase, and put on all the organizational political factors which might also influence. So we have to remove away all the noise factors, concentrate and focus only on the development of the software. That will enable to deliver what has been promised in the most efficient manner. Followed by which we are going to talk about the requirement specification. Now, when I come to this word specification itself, it's a kind of document that's created by software analysts, and after the requirements are collected from various sources, the requirement received by the customer is written in ordinary language. Now, this is very, very important. When I say the word specification, it means to say that what exactly as a software analyst would look into it, and I'm trying to write down this entire thing in an ordinary language, in a plain English. Why? Because that's exactly where an analyst will try to make you understand his requirements. Normally, we are carried away with so much of technical jargons and words that sometimes we miss out on plain simple things. So as a software analyst, it's your primary duty to understand what is exactly required for the project at that given point of time, and try to match those requirements using a plain simple communicative process. Many a times, if the communication goes wrong, or if it goes beyond what is necessary or needed, the project might get completely collapsed. So that is the reason where we try to bring in the specification factor, specify exactly what is needed, communicate it to the customer, make the customer understand whether we are on the same page, and then you can start getting to the development team and build the best software possible. So everywhere, what is needed by us is that to understand the specifications better, which can make us understand how things develop. Now, the next thing is that the models used at this stage could be the entity relationship diagrams, the data flow diagrams, the decomposition diagrams, the functional decomposition, the data dictionaries, and all those factors. Now, what is a data flow diagram altogether? These are widely used for modeling requirements. The data flow diagram will allow the data to flow through the system. The system may be company, organization, set, a procedure, a set of documentations, and every factors that we are talking about to make the software. Now, whenever I say the word data flow, it is about a structured system that's going to take you through the various steps that are involved for the requirement. So whenever we are putting in this data flow diagram, we want to understand whether it can match the system, the set of procedures are exactly in place to develop it. So this is like a pictorial representation rather than just writing down the theory factor, and this can form a better impression in the minds of consumers as well as the business team. Why? Because they understand what exactly that is being picturized there, what exactly is needed in terms of building up that particular system. Now, followed by which the data dictionaries, they are simply repositories to store information about all data is defined in DFT. Now, the word dictionary is quite interesting. Why? Because just like any other dictionary, the data dictionary is going to hold all the data that you might find needed for the system. So suddenly I'm finding something, I want more information about what you have spoken in the DFD. I go to the data dictionary, I can find out at what stage, what data, what document is required, and how those things will really matter to us. So in that sense, case, what will happen is that the customers and developers use same definitions and terminologies, which is very, very important for all of us. Followed by the entity relationship diagram. Another tool for requirement specification is the entity relationship diagram, and this is also called as the ER diagram. It's a detailed logical representation of data for the organization, and it has three main constructs altogether through which they are associated and attributes altogether. So you can understand the entire factors of how they are doing it, how it needs to be structured, how it needs to be taken forward. So this will actually help you to build the entire phenomenon, the entire structuring phase altogether. Now, followed by which we have the validation, which is very important. Why validation? Validation is something that is going to tell whatever we have done is correct or not. At the end of the day, when the document is validated, there might be instances where you might still find that certain things are not possible. Certain things are beyond the limits. Certain things are not prescribed as per the project. So validation is that checklist step where you would try to understand, is everything correctly understood? Are there any changes? Are there any further requirements? Any ambiguities are there? Is the customer and the client team and the people are on the same page? If there's anything that needs further description, do we need to write down things more practically, more detailed version? All those things will come under the validation phase. This stage is very important. Why? Because if you skip the validation, then you might land up in errors which cannot be rectified in future. So instead of wasting the time debugging the entire software at the end of the day, you could probably spend more time on the validation, trying to understand what is essential. Where are all the gaps? Where are all the ambiguities? Where are all the factors that needs to be understood? And then we could probably do things far better. Followed by which we come to the validation in terms of the inspections review, the prototyping, which is very, very important so that you get an exact model, trying to understand the replica, how does it work, the test case generation, which is very, very important. Why? Because every time in the test case, we try to replicate exactly the working model. So if there might be any problem, it might be a login, it might be a small radio button, it might be a submit button moving on to the next page, it might be about some screen alignment. Whatever are the changes that we are talking about, a test case needs to be generated, and if an error is found, it's the foremost duty of the tester to send that with the screenshot to the development team, understand what changes are required by the consumer and get it done. So automated consistency analysis, checking for the consistency of the structure, whether it's falling on to the same level and same level of activities. Followed by which the requirement management is also important because it tries to talk about the engineering process, how it is being done, what are all the new developments, the priority that is different from, at different stands from the viewpoints, because somebody might have a different set of requirements, somebody will have a better understanding in some other set. So it is very important for all of us to understand the priorities of the project. Finally, the prerequisite, which talks about needs to be clear, it needs to be correct, consistent, coherent, and comprehensible. So when you do this entire requirement engineering analysis, the contents need to be clear enough, need to be a correct content, it has to be consistent in terms of the flow of data, it should be coherent, which means meaningful, and comprehensible, understandable to all of us. Then only this entire requirement analysis will get completed. Now, the most important thing that we also need to see here is that, is it modifiable? Can we bring in changes into it? Verifiable? Can I validate it at each and every step? Prioritize one by one, step by step. What is the top priority? Which needs to be addressed first? Which needs to come second? Unambiguous. There should not be any sort of confusion. There should not be any sort of unclear thing. So everything has to be clear enough. Traceable, which means to say it is transparent enough. Whatever happens, there needs to be a flow. Whether it's be right or wrong, yes, I can track it. I can find out where exactly the mistake is. So it needs to be traceable. Credible source, trustworthy. When I giving you the project, when a consumer is giving you the project, the client entrusts the trust factor into the company. So when you're doing the project should be credible enough so that you maintain your name as well as the brand and the source of the software. Now, the other thing is the software requirements, which are largely on the requirements in terms of the functional and the other factors. The functional requirements we have been speaking about, which is trying to talk about documentation, the business formalities, how it needs to be addressed, and what are all the system functionality. Followed by the non-functional, which talks about only the operational factors that needs to decide. We are going to talk about execution and evolution qualities, which means to say that how the project is going to work, where are all the structure and factors that we need to concentrate upon. With this, I come to the end of this particular session. I hope and believe that all the factors that have been spoken here in this particular session will be of a great help to you, both in terms of practical as well as from the theoretical walk of life. In the upcoming sessions, we would be talking more about software engineering in terms of the test cases, the various other requirements, and how the entire software models are designed. But until then, stay tuned, stay blessed, and thank you once again for being with me on this wonderful session.